That's really the key is reducing the size of the thermal component of these plants because it is the highest capex and the highest opex portion of these wastewater treatment plants.
Hey everyone, it's Bob Crossan. I'm the editorial director for Wastewater Digest. I'm joined today by Eric Kadaj. He's Senior Director of Market and Applications Development for Energy Recovery, and we're going to be talking about resource recovery for wastewater treatment systems. So, Eric, thank you so much for taking your time and speaking with me today.
Thanks for having me, Bob. I'm excited to talk about this topic.
Yeah, I think resource recovery is becoming a bigger thing of concern or question that utilities are having, especially on the wastewater side, knowing all these nutrient limits that are coming down too. What resource recovery options currently do exist for wastewater treatment systems today? Are there certain technologies that people are gravitating toward?
There's a few. There's a few. So when we think about resource recovery, I think about it in two different ways. One is with municipal wastewater treatment systems, and then in industrial wastewater treatment
Hmm.
systems as well. So for municipal wastewater systems, there typically is a biological option, something like an anaerobic or aerobic digester. Those are typically used, and then some type of thermal process at the end to dewater the rest of the stream. On the industrial side, and also and on the municipal side to a certain degree, we're starting to see reverse osmosis membrane treatment systems starting to be used now that the discharge requirements are becoming more strict.
Hmm.
Different types of RO. There's standard reverse osmosis, then you have ultra high pressure RO. There's some new processes referred to as osmotically assisted RO,
Hmm.
CFRO, cross flow RO. There's a lot of acronyms out there, but mainly there's some type of reverse osmosis treatment train as part of these wastewater treatment systems.
Hmm. And then what about the industrial side? You mentioned that there's a different component there. Are they using other things than the biological side of things?
Yes, so because of the different constituents in the water on the industrial wastewater side, the reason why biological is used on the municipal side is because there's a lot of, as you would expect, in sewage treatment plants, there's a lot of biological waste that needs to be broken down. Whereas on the industrial side, this is where we're seeing a lot of innovation when it comes to resource recovery, and going to higher and higher concentrations to dewater those fluid streams.
Mhm. So what resources are commonly being recovered and how are they used or repurposed when it comes to those municipal applications?
So for municipal applications, the most common resources being recovered are those types of resources that can be used for fertilizer. So as you
Mm,
would imagine with human waste or sewage, there's a lot of biological remnants in that fluid, phosphorus being one of the highest ones. So you're seeing a lot of dewatering and that being used for organic fertilizers that you would use on your lawn. There are a few different brands out there that literally take waste from a sewage treatment plant and sell it as lawn fertilizer.
mm,
Uh, on the municipal side, on the industrial side, we're seeing resource recovery. One of the areas we're seeing a lot of innovation right now is in the lithium space. So we have worked with some end users in China specifically, where on the lithium side, when they're manufacturing the cathode, which is part of the battery for these large electric vehicle batteries that are becoming more popular. On the waste side of that process, there's a lot of ammonium sulfate and ammonium nitrate that's a byproduct of the process to create the cathode. And ammonium sulfate and ammonium nitrate are again constituents of fertilizer. So what they're doing is they're using ultra high pressure RO and the pressure exchangers that we manufacture to save that energy, because these ultra high pressure RO and these brine concentration processes are quite energy intensive.
mhm.
So they're recovering those types of constituents as well.
Yeah. So where do you see the future of resource recovery going when both in the municipal and the industrial context? Are there certain things that water and wastewater plant operators or owners should be considering as they look forward and know that they could capture some of these things and maybe even get some revenue off of it?
So on the municipal side, there's a lot of talk about PFAS, right? So
Yeah.
when we talk about PFAS, a lot of people are concerned with, and a lot of end users are concerned with eliminating the PFAS from the water that's going to be sent out to the distribution system for
Hmm.
reuse or to be discharged back into an aquifer or just discharged back into the environment. And that's true. PFAS needs to be removed from that. But what you do when you remove all the PFAS from the water that you're discharging, it's being concentrated on the waste side of the operation. So where there needs to be some innovation is actually destroying this PFAS, so it's in neither one of these streams. Because if these operators want to recover resources from the waste stream, you're going to be recovering PFAS and the like as well. So there needs to be some innovation there, and RO can help to a certain degree in concentrating up those brine streams before it goes to a thermal process, and that's really where RO is starting to gain a foothold, is reducing the flow of these waste streams so that you can reduce the size of these thermal processes. And we saw something similar in the desalination space 20 years ago, where thermal processes were the only technology, or the traditional technology, and membranes eventually replaced those processes, to the point now where there are almost no thermal desalination plants
Hmm.
anywhere in the world. And the pressure exchanger that we manufacture is a big part of reducing the cost to operate these membrane treatment systems as well.
Yeah. Do you think there will be changes in any best practices when it comes to resource recovery over the coming years, or is it going to remain mostly the same and the technology is how you're going to be seeing most of the change?
It'll probably be more on the technology. There are ways that you can reduce and recover these resources with the technology that there is now. But unfortunately, the technology at this point needs to be improved, and we need to start
Mhm.
going to these higher and higher pressures, or going with, as I referred to before, the osmotically assisted RO, these different types of processes that can be used to concentrate these brine streams and reduce the size of the thermal systems. That's really the key, is reducing the size of the thermal component of these plants, because it is the highest capex and the highest opex portion of these wastewater treatment plants. So that's where the industry is moving, and reducing that opex through both process innovation and then energy recovery device innovation as well, is really going to be a key to moving everything forward.
Oh yeah, energy being it's such a huge portion of these utilities
It
budgets.
really is. It
Anything
really
you can
is.
do to drop it down a little bit, they feel it tremendously. So, well, thank you so much,
Absolutely.
Eric. I really appreciate you taking the time and chatting with me. I definitely feel like I've learned about this more deeply than I ever have, and I hope our audience has too. So, thank you for your time. We really appreciate it.
Thanks, Bob, for having me. Hope to do it again soon.
Yeah, and for everyone who's watching, check out our video description below. We'll have some links to some articles that we've published from resource recovery and some other things that are on our website regarding resource recovery. Thank you so much.